Hello students, today I am going to discuss on the topic geological timescale and appearance of man. Let me first give you some introductory notes on this topic. The history of Earth is a very complex and vast subject which deals with the appearance of all the living and non-living matter. The formation of rocks, minerals, and different geomorphological features, besides birth and evolution of simple unicellular microorganisms to modern human beings, are subject matter of the history of the Earth. Impossibility of devising a calendrical time frame as in the case of historical phase. Attempts have been made to try to understand the history of the Earth chronologically in terms of formation of rock layers and related life form in different stages termed as era, period, and epochs. The significant event in the history of the Earth is the evolution of man during the Pleistocene epoch. The formation and development of vegetation from simple lichen-like forms to woodland through ages also form an inseparable part of it. The occurrence and development of particular rock strata and corresponding life forms together with associated environment are different events in the history of the Earth. Consider for chronological succession in the event of impossibility of devising a time frame with calendrical accuracy. Thus, the geological time scale provides a system of chronological measurement relating stratigraphy to time that is used by geologists, paleontologists, and other scientists to describe the timing and relationship between events that have occurred during the history of the Earth. British geologists were responsible for the grouping of periods into eras and the subdivision of tertiary and quaternary periods into epoch. William Smith in 1950 and Charles Lyell in 1930 first recognized that rock strata represented successive time periods. Time scales could be estimated only very imprecisely since various kinds of rates of change used in the estimation were highly variable. Geologists and paleontologists constructed the geologic level based on the relative position of different strata and fossils, and estimated the time scale based on studying the rate of various kinds of weathering, erosion, sedimentation, and lithification. The first geological time scale was eventually published in 1913 by the British geologist Arthur Thomas. He greatly furthered the newly created discipline of geochronology and published the world-renowned book, The Age of the Earth, in which he estimated the Earth's age to be at least 1.6 billion years. The Earth carries the history of geological events in its rock layers. It follows that the oldest layers are at the bottom and the youngest are at the top. With this understanding, geologists are able to determine the ages of rock relative to one another. In order to simplify the huge amount of geological information, Geologists have broken Earth's history down into sections which are called geological eras, periods, and epochs. Fossil records have shown that life existed for about 3.800 million years. Their fossil records allows geologists to date and compare rocks across geological time. In 1977, the Global Commission of Stratigraphy, now the International Commission on Stratigraphy, started an effort to define global reference, global boundary stratotype sections and points GSSP for geologic period and faunal stages. On the basis of worldwide data, a standard chart has been prepared to understand the geological time scale. This list is divided first into the geologic eras of the Phanerozoic and then into the geologic periods of each era. Each period has its own table in which it is subdivided into epochs and stages. Each stage is assigned an age in millions of years ago, an acronym for million years ago, which is the age at which it began. Most of these ages are derived from astronomical cycles in sediments. Magnetic data, biostratigraphic data, and radiometric dating methods. The worldwide geological community is formally considering whether the Anthropocene should join other more familiar units on the geological time scale. The Anthropocene represents a new phase in the history of both humankind and of the earth, when natural forces and human forces became intertwined, so that the fate of one determines the fate of the other. Geologically, this is a remarkable episode in the history of this planet. An epoch is a division of the geological time scale. Epochs are subdivisions of periods and are themselves subdivided into ages. The time span of an epoch can differ, but is usually between 50 and 5 million years. The youngest episode of the geologic time scale are even shorter. The Pliocene and Pleistocene epochs lasted less than 3 million years, and the Holocene epoch lasts only 10,000 years. The earliest ancestors of humans were members of the genus Australopithecus, the intermediate between apes and men. Both Australopithecines and humans are biologically similar enough to be classified as members of the same biological tribe, the hominin. All people, past and present, along with the Australopithecines, are hominin. Over the last decade, there have been a number of important fossil discoveries in Africa, of what may be very early transitional ape, hominin, or proto-hominin. These creatures lived just after the divergence from our common hominid ancestor with chimpanzees and bonobos during the late Miocene and early Pliocene epochs. The fossils have been tentatively classified as members of three distinct genera: Sahelanthropus, Ororhyn, and Ardipithecus. The earliest Australopithecines did not evolve until 5 million years ago or shortly thereafter in East Africa. The primate fossil record of this crucial transitional period leading to Australopithecine is still scanty. However, by about 4.2 million years ago, unquestionable Australopithecines were present. By 3 million years ago, they were common in both East and South Africa. The same hominin types have also been found dating to this period in North Central Africa also. As the Australopithecines evolved, they exploited more types of environment. The Australopithecines took advantage of these new conditions. In the more open environment, bipedalism would very likely have been an advantage. By 2.5 million years ago, there were at least two evolutionary lines. Hominin descended from the early Australopithecines. One line apparently was adapted primarily to the food resources in the lake margin grassland environment and had an omnivorous diet that increasingly included meat. Among them were our early human ancestors who started to make stone tools by this time. The other line seems to have lived more in mixed grassland and woodland environment, like the earlier Australopithecines, and was primarily vegetarian. This second, more conservative line of early hominin died out by 1 million years ago or shortly before then. It is likely that all of the early hominin, including humans, supplemented their diets with protein and fat-rich termites, just the same as chimpanzees do today. The evolutionary surge that led to Homo habilis began towards the end of the Pliocene epoch, around 2.5 million years ago, when climates were becoming cooler and drier. The evolution of Homo erectus and later species of humans occurred during the Pleistocene epoch, that is around 1.8 million years to 10,000 years ago. The Pleistocene was generally a time of more extreme warmth, cooling and recurrent glaciations, that is ice age. Scientific evidences indicate that humans evolved into their present form during the Pleistocene. According to mitochondrial DNA analysis, modern humans migrated from Africa after the Ries glaciation in the Middle Paleolithic during the Eemian stage, spreading all over the world, ice-free world during the late Pleistocene. Homo erectus moved from scavenging to hunting, developing the hunting-gathering lifestyle that would remain dominant throughout the Paleolithic into the Mesolithic. The unlocking of the new niche of hunting-gathering subsistence drove a number of further changes, behavioral and physiological, leading to the appearance of Homo heidelbergensis by some 6 lakh years ago. Homo erectus migrated out of Africa and dispersed throughout Eurasia. Stone tools in Malaysia have been dated to be 1.83 million years old. The packing man fossil discovered in 1929 is roughly 70,000 years old. In Europe, the Oldowan tradition, also known in Europe as Abybilian, split into two parallel traditions, the Clactonian, a flag tradition, and the Acheulean, a Handex tradition. The Levallois technique for knapping flint developed during this time. The carrier species from Africa to Europe undoubtedly was Homo erectus. This type of human is more clearly linked to the flag tradition, which spread across southern Europe through the Balkans to appear relatively densely in Southeast Asia. Many Mousterian finds in the Middle Paleolithic have been named using a Levallois technique, suggesting that Neanderthals evolved from Homo erectus. According to Bishop and others, in 2003, the first proto-Neanderthal traits appeared in Europe as early as 600,000 to 350,000 years ago. Several cultural assemblages have been linked to the Neanderthals in Europe. The earliest Mousterian stone tool culture dates to about 300,000 years ago. Later Mousterian culture is also seen in Asia and in Africa, dated after 150,000 years ago. At the Jabal Ayraut site, located 620 km south of Gibraltar, late Mousterian artifacts were found in Gorham's Cave on the remote south-facing coast of Gibraltar. Other tool cultures associated with Neanderthal include Aurignacian, Gravettian, developed with gradual continuity, not distributed by population scenes. Early Neanderthal lived in last glacial age for a span of about 100,000 years. Because of the damaging effects the glacial period had on the Neanderthal sites, not much is known about the early species. Countries where their remains are known include most of Europe, south of the line of glaciation, roughly along the 50th parallel north, including most of Western Europe. Some sites are also reported from Ukraine and in western Russia and east of Europe up to the Indus River. The Neanderthals disappeared from the fossil record after about 25,000 years ago. The last traces of Mousterian culture without human specimens have been found in Gorham's Cave on the remote south-facing coast of Gibraltar about 30,000 to 24,000 years ago. Human skeletal remains from the German site of Vogelhart, so far regarded as the best association between anatomically modern Homo sapiens and Aurignacian culture, were revealed to represent intrusive Neolithic burials into the Aurignacian levels, and subsequently all the key Vogelhart fossils were now dated to 3,900 to 5,000 years ago instead. Homo sapiens are the only living species in the Homo genus. Anatomically, modern human originated in Africa about 200,000 years ago, reaching full behavioral modernity around 50,000 years ago. Anatomically modern humans evolved from archaic Homo sapiens in Africa in the Middle Paleolithic about 200,000 years ago. By the beginning of Upper Paleolithic period, full behavioral modernity including language, music and other cultural universals had developed. Dear students, now let me come to the concluding remark. The term human in the context of human evolution refers to the genus Homo, but studies of human evolution usually include other hominids such as Australopithecines, from which the genus Homo diverged by about 2.3 to 2.4 million years ago in Africa. Scientists have estimated that humans branched off from their common ancestors with chimpanzees about 5 to 7 million years ago. Several species and subspecies of Homo evolved and are now extinct, introgress or extinct. Examples include Homo erectus, Neanderthals, archaic Homo sapiens, the forerunners of anatomically modern humans, evolved between 400,000 and 250,000 years ago. With the help of geological timescale, the various stages of human species can be studied properly. Thank you all for patient hearing.